trapezoids and kites, right? And they have lots of little properties. Well, now we're going to talk about parallelograms. And they have their own properties. Okay, so you need to make sure that you learn these properties really well because then we're going to add to it the next days. Okay. So first of all, you need to understand the definition of a parallelogram. It is a quadrilateral with both pairs of opposite sides parallel. Okay, so you got this pair of opposite sides, AB and BC parallel, and then AB and BC are parallel. Okay, so both pairs of opposite sides are parallel, which is different than a trapezoid because the trapezoid only had one pair, and a kite had no pairs. Okay, so that's why it's its own unique shape. This is as simple. You do like a little mini parallelogram, and then you list the vertices in clockwise or counterclockwise order. So ABC. Okay. All right. Now, I want us to kind of discover the properties. Okay. Of the parallelogram. And so we want to look at how do the length of the opposite sides of a parallelogram compare with each other. What do you think? We know the opposite sides are parallel, but what else do we know about them? Are they congruent? How do you know? Well, not necessarily, because if you go back and think of the trapezoid, right? They only have one pair. They're not, right? So you can't just say because they are parallel. What if I take, and I want you to remember that your the opposite sides are parallel to each other. So let's say I drew a diagonal. Okay? That's a diagonal. Now, remember, this side here is parallel to this side here. Okay? What do I know? Well, no, doesn't this show this split in half? No, change diagonal. Remember we talked about parallelogram, if you folded it in half, it doesn't break it exactly in half. Well, I mean, yes it does, but not symmetrical. What can we get from the fact that these two right here are parallel with each other? Yes. You have some angles that are congruent, that's safe. Okay, yes. Alternate interior angles. Okay. So I know that because these two lines are parallel cut by this transversal, these alternate interior angles are congruent, right? Okay. And then likewise, if I look at these two parallel lines in the same transversal, I have my other pair of alternate interior angles that are congruent. Yes? Okay. And so if that's true, you notice that they share the diagonal, correct? Right? So they share the diagonal. So what does that make true about those two triangles? Yes. They're congruent by what? Angle side angle, right? And so if they're congruent by angle side angle, then all of the corresponding parts are congruent, yes? Okay. So that means that this side is congruent to this side, right? And this side is congruent to that side. Okay. Now you all knew that was true, but now you know why it's true, right? Okay. So we've learned that opposite sides are congruent. And so they stated that as a theorem. They went to like, components of long proof of it. We just kind of talked about it. But if a quadrilateral is a parallelogram, then the opposite sides are congruent. So xy is congruent to p, and xw is congruent to y. Okay, so with that said, given this problem, if I want to find the value of x, what would I do? Okay, so you're going to take the fact that these two are congruent, right? Okay, so I would take 7x minus 3 equals 2x plus 12. So that gives me 5x equals 15. Divide those guys by 5, and x is 3. Okay, so that gives me this x is 3. Now, could I have used 4x equals 5x minus 3? I could have done that. Could I have said 4x equals 7x minus 3? No. Okay, we do not know that consecutive sides are congruent. Okay, just opposite sides. Okay, so then what is the length of each side? Well, we know that QR and PS are equal, right? And so if we plug 3 in for that, that would give me what? 18, good. Okay, and then we also know that QP and RS are equal, and so if I plug 3 into that, I would get 12. Okay, so I found X, and we found both pairs of sides. A 600-meter fence around City Park forms a parallelogram. The fence along Chaco Road is twice as long as the fence along Grover Lane. What is the length of the fence along Jones Road? Okay, so let's see what we got. We know it's parallelogram. It says the fence along Chaco Road is twice as long as the fence along Grover Lane. We know how long Grover Lane is. No, so we're going to let that be our X, right? And then Chaco Road is 2X. Now it's a parallelogram, so what do we know about opposite sides? Okay, Village Drive is 2X, and then Jones Road is 2X. And we know that all the way around is what? 600, right? A 600-meter fence around City Park. Okay, so if I add everything together, then 4, 6X equals 600, and so X is 100, okay? So what is the length along Jones Road? So Jones Road is X, right? So it would be 100 meters. 100 meters. Okay, so far we know that in a parallelogram, opposite sides are parallel and opposite sides are congruent. Okay. How can you use what you know of, how are the consecutive angles in a parallelogram related? You can use what you know about angle relationships formed when parallel lines are cut by transversal. Alright, so let's take these parallel lines and let's cut by a transversal, right? What do we do? You can see here what? They're supplementary, right? Because they're consecutive angles. They're same side. So we know that the measure of angle B plus the measure of angle C equals 180, right? Okay. So then what if I look at AD and BC? That they're parallel cut by AD. What can I say? They're supplementary also. So the measure of angle A plus the measure of angle B equals 180. And honestly, I could go all the way around, couldn't I? Okay, I could say that, oh, that's it. Because I was talking about these two. Oh, no. Okay, so I talked about these two are supplementary, then these two are supplementary. Then I'm going to talk about these two are supplementary. So the measure of angle A plus the measure of angle D equals 180. And then the final pair, the measure of angle D plus the measure of angle C equals 180. My same side interior are supplementary all the way around, right? Because we've got parallel lines cut by a transversal. Okay, so we know that that's going to be true. So we can say that consecutive angles are supplementary. Okay? Consecutive angles are supplementary. Okay, so how are the opposite angles in a parallelogram related? Huh? They equal 180? That's what you said. Oh, they're congruent. Okay, how do you know? So they're both supplementary to the same angle, right? Okay, that was the congruent, supplement theorem? I think that's what it was called. May not be what it was called, right? But this, like, angle A is supplementary to B, and angle C is supplementary to B, right? So A and C basically these two statements, right? Okay, and they're both equal to 180, yes? Okay, they're both equal to 180, so honestly I can set them equal to each other, because they're both equal to the same thing. You agree? So I could say that the measure of angle B plus the measure of angle C equals the measure of angle A plus the measure of angle B. And I can subtract B from both sides, couldn't I? And so then I get the measure of angle C equals the measure of angle A, which is what I just said, right? Okay, it's just coming here. And the same thing would be true here. So there's a little proof of it, or you could remember the congruent supplements here. So opposite angles are congruent. So they wrote those at both as a theorem. If the quadrilateral is a parallelogram, then the angles are supplementary. Okay? And if the quadrilateral is a parallelogram, then opposite angles are congruent. So far, in a parallelogram, you have opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, consecutive sides angles are supplementary. Okay? Alright, so let's look at this question. The green shape in the fabric design is a parallelogram. Okay? So this green shape right here is a parallelogram. The measure of angle 2 is twice the measure of angle 1. Find 1, 2, and 3. Okay, so what is 1? Do we know? Okay, which means that 2 is going to be 2x, and so it's 3, right? They're the same. What can I do to find x? All three of them. Remember, we got these are parallel, cut by this transversal, right? You're going to add these two, you're going to add 1 and 2 together instead of equal to 180. So x plus 2x equals 180. So that's 3x equals 180. And so x is 60, which is angle 1, right? And then the measure of angle 2 and the measure of angle 3 is what? 120. Alright, here's another one. Use the parallelogram shown. Given the parallelogram GHJK, what is the value of A? Okay, these are consecutive angles, right? So you're going to add them together instead of equal to 180. So we get A plus 5 plus 8A minus 5 equals 180. So that's 9A equals 180. Divide both sides by 9, and A is what? 20. Okay, so A is 20. Then we need to find all the angles, right? Okay, so if we find H, what do we know about H? It's congruent to K. So the measure of angle H equals the measure of angle K. And if I plug 20 in there, what does it make both those? Huh? 25. Okay, and then we also know that the measure of angle G equals the measure of angle J. Okay, and I can plug into that, right? Or what do I know about it? What's the relationship? They're supplementary, so subtract from 180, and what's that give me? 155. So either way, or just subtract from the 25 from 180. Alright. One more discovery here. How are the diagonals in the parallelogram? Well, remember I have parallel lines. What do you think, first of all? What do you think is going to be true about the diagonals? Think they're going to be congruent? Are they going to bisect? Are they going to bisect the angle? Are they going to bisect each other? What do you think? Huh? Each other? You think they're going to bisect the angle? I don't think so. There's look at that. Think they're going to bisect each other? Okay, let's figure this out. Okay, we have parallel lines cut by this transverse, right? Okay, so if that's true, then what can we determine? 2 and what? 2 and 3 are congruent, yes. Okay, so 2 and 3 are congruent. Okay, and then here's another transversal, and we still have the parallel lines. So these are congruent, right? Okay, and it's a parallelogram. What else do we know about parallelograms? You said the two triangles are congruent, but how? Where's the side? Well, the vertical angle, that would be angle, and that would work. VA and CD, how do we know that? That doesn't mean that they're congruent. We know that they're congruent, but why? Did we just learn that if it's a parallelogram, opposite sides are congruent, right? Okay. Alright, so yes, now these triangles are congruent by angle, side, angle, which means that these two sides are congruent, right? And these two sides are congruent. Okay? So yes, the diagonals bisect each other. They don't bisect angles though, and they aren't congruent. Okay? So the diagonals bisect each other. Okay, which is what this theorem here states. If a quadrilateral is a parallelogram, then its diagonals bisect each other. Okay. Alright, so use parallelogram RSTU with SU, which is 35, and KT, which is 19. What is SK? Okay, so how'd you get that? It's bisected. The whole thing is 35 divided by 2, right? Okay, so it's 17.5. And then what about RT? Okay, you doubled this, right? They're both 19, and so it would be 38. Alright, so what did we learn about parallelograms? First of all, what makes it a parallel? Two opposite sides parallel, that's the definition, right? Okay. Then we learned that, what else about the opposite sides? They're congruent. What about opposite angles? They're congruent. What about consecutive angles? They're supplementary. What about triangles? They bisect each other. Memorize those properties. Okay? We're going to talk about them again tomorrow. Okay? Then we're going to add in rectangles on by squares. They have their own properties too. And the trapezoid and the kite have their own properties. You see why it makes it easy?